Okay, so lesson number 3 continues on what we did yesterday with converting from an entire radical to a mixed radical or a mixed radical to an entire. Only this time we're not just looking at square roots. We're looking at cubed roots or fourth roots or fifth roots and looking at that process. So, like a square root, when we were trying to convert an entire square root radical into a mixed square root radical, we had our list of perfect squares that we were looking at. If my index is a 3, or if it's a cubed root, now what I have to consider is my list of cubed or perfect cubed numbers. So 1, 8, 27, 64. So if I have a number like 54, and I'm trying to change the cubed root of 54 into a mixed radical, what I look for is, can I divide 54 by one of these numbers, by one of these perfect cubed numbers? And the answer is yes. I can divide it by 27. And I get 27 times 2. So then I can separate this to be the cubed root of 27 times the cubed root of 2. This is the step that I generally don't actually show. The cubed root of 27 is going to be equal to 3. So this becomes 3 times the cubed root of 2. So then I can say that the cubed root of 54 equals 3 times the cubed root of 2. And again, the thing to remember is this 3 has to be shown smaller, almost like an exponent fitting into that checked part of my radical symbol. Okay, so if I look at class example number 1, A and C are both cubed roots, so we can use our list of perfect cubes. For B, we're going to do that one a little bit different because it's a fifth root. So, first of all, let's look at the cubed root of 6,000. According to this chart that you have here on your page, what number could I divide 6,000 by? 1,000. So I would get the cubed root 1,000 times what? 6. Okay. I generally put my perfect cube number first. What is the cubed root of 1,000? 10. So I get 10 times the cubed root of 6. The only other thing that I should check is, could I divide 6 by one of those perfect cube numbers? I want to make sure that 6 is the simplest radical that I could have. And it is. Okay, so let's look at 3. Or sorry, C. Can I divide negative 16 by a perfect cube number? 8. Should it be negative 8 times 2, or should it be 8 times negative 2? Does the negative matter? Does it matter which one it's with? Probably not. Can I find the cubed root of negative 8? What would it be? Negative 2. So I could have this as being negative 2 times the cubed root of 2, or I could have had 8 times negative 2, in which this would have been 2 times the cubed root of negative 2. Either answer would be acceptable, although generally if we can pull the negative from outside the radical sign, we would. Okay, so that leaves us with B. If you have an index that is more than 3, because perfect square numbers and perfect cube numbers we should be able to get a handle on, but trying to find perfect numbers to the power of 4 to the power of 5 starts to become a little bit harder. So what we're going to actually do is we're going to go back to prime factorization. So if I think of the number 320, if I divide 320 by 2, because I know 2 is a prime number, so we're going to start with our 2's. Divide 320 by 2, what do I get? 160. Can I divide 160 by 2? what do I get?
80.
Can I divide 80 by 2?
Yeah.
What do I get? 40. Can I divide 40 by 2? What do I get?
20.
Can I divide 20 by 2?
Yeah.
What do I get?
10.
Can I divide 10 by 2? What do I get?
5.
And can I divide 5 by, I can't divide it by 2, but what can I divide it by? 5. This is the prime factorization for 320. 5 times 2 is 10, 20, 40, 80, 160, 320. And this is the 5th root. So if it's the 5th root, I need a number that I can multiply by itself 5 times. That's the number that I'm multiplying it by itself 5 times. So the 5th root would be taking the 2 out. And then leaving me with whatever is inside, or whatever is left. This 2 and the 5. So then I get 2 times the 5th root of 10. Okay. You're not going to see a lot of these questions. I might throw one at you during the course of the entire semester. Most of the time we're going to deal with cubed roots and square roots. But if you did have something that was the 4th root or the 5th root or even the 6th root, bring it to its prime factorization, and then you were looking for the same number of factors as what this index is. So if the index was 6, I could still take that 2 out because I have 6 of those 2's being multiplied. What is 2 times 2? 4 times 2? 8 times 2? 16 times 2? 32. And if I found the 5th root of 32, my answer would be 2. Okay? So if I go backwards, going from a mixed radical to an entire radical, when we did our square roots, when we wanted to put the number back underneath the radical sign, I had to square it. If I want to take a number and put it under the cubed root sign, I would have to cube it. So I would take my 1/2 and I would cube it. So if I take 1/2 and if I raise it to the power of 3, raise both of these to the power of 3. So 1 to the power of 3 is 3. 2 to the power of 3, 8. So I get the cubed root of 1/8 times 80. And if I didn't use a calculator for this, 8 is on the top, 8 is on the bottom. So think of it as division. 80 divided by 8, 10. So the 1/2 times the cubed root of 80 would be the same thing as the cubed root of 10. Okay, so we have a couple of examples on the next page. So I'm going to look at B and C first, and then we'll do A and D afterwards. So if I look at B, if I want to take this -4 and put it inside the radical, I would take the -4 and I can cube it. Why can I put the negative inside the radical this time? Because yesterday we didn't.
Because you're going to get a negative.
Because I can actually take the cubed root of a negative number. So -4 to the power of 3 times 7 equals what? If you didn't put the negative inside, you could get this. And I would still mark it correct. So the negative could be inside or it could be outside. If I look at C, it is 2/5 times the cubed root of 100. So when I put the 2/5 underneath, I would cube it and then multiply it by 100. And tell me what you would get. So if I put this in my calculator, or not, so 2/5 I would put in brackets to the power of 3 and then multiply it by 100. Oops. Okay. Multiply by 100. I get 6.4, but if I wanted to keep it as a fraction, 32/5. So the cubed root of 32/5. If we look at A, it's a 4th root. So when I put the 2 underneath the radical sign, I would raise it to the power of 4. So then on my calculator, it would be 2 to the power of 4. And to get that, 2, and then there's my power button, to the power of 4 times 3, and I would get 48. So I'd have the 4th root of 48. With D, if I put the number underneath the radical sign, do I put the negative under there as well?
No,
Why not?
because it will become positive.
This is an even index, so the negative has to stay on the outside. And it's just the 3 that I would put inside. So then 3 to the power of 4 times 2 would equal, Delana, I'll wait for you to do that and then you can tell me the answer.
Because if you go like this, times that, and if you go like that, it's like that.
What'd you get?
Yes.
Okay.
7.6. 1, yeah, but then you're at 7.6.
Don't put the radical symbol in there, Delana. Just 3 to the power of 4 times 2. So I'd have negative 4th root of 162.